if we look at the really popular approaches to forecasting, they are time series graph, which is basically just looking at the particular variable that we're interested in plotted over time. And that is a fantastic way of doing forecasting. It's a great place to start, and often that will give you all the information that you need to make your forecasts. Now, also moving averages or smoothing. Now, you might have seen quite a lot of this being done with the coronavirus that's taking place at the moment. So when you see, for example, the daily infection rates, it kind of jumps up and down quite a lot day to day, but they'll put a smoothing line on that. We'll talk about that. Linear regression can be used also. It's quite a popular approach in forecasting, although we need to be careful doing linear regression with forecasting, and I'll explain why that is. And also I'll talk very briefly about time series models to model seasonality and trend, which actually are very difficult and starting to get pretty advanced. So we're not going to deal with that directly on this module. So the key thing about forecasting is to obviously make predictions about what's going to happen in the future. And the key concern we have is how confident are we in our predictions? Ultimately, anybody can make a prediction. The question is, how confident are we in those predictions? And it's very important that we are honest about that. It's no good pretending that we have really good predictions if we don't. It's much better to be honest, then at least you can prepare for that uncertainty. So here's a very good example. This is the S&P 500, which is essentially the stock market in the USA. And here we can see it plotted from 1950 all the way to 2016. Now, many people have tried to predict the future of the stock market, and it's notoriously difficult. I mean, you can see over that period of 66 years, you can see that there's a clear positive upward trend towards the stock market. But you can also see that there's a lot of variability. The stock market goes up and down a lot in fairly short periods of time. And also there's some pretty big drops in that stock market. You can see there's one around 2002 and another one around 2009. And obviously those big changes in the stock market are very unpredictable because they're clearly big environmental shocks. So you can see that when it comes to forecasting, we're really trying to understand whether there might be some kind of trend in the data, and also whether there is any regularity to the ups and downs within the data that we're seeing. So let's have a little bit more of a look at that. So the first step for forecasting is to look at a time series graph. So that means we look at a graph of the key variable that we're interested in over time. So here, for example, we have data which relates to applications for a postgraduate course over time. Okay, so we can see that we have 19 observation over a period of time. Now, when you're doing this type of time series analysis, there's two things that you're looking for. You're looking for to answer two questions. Is there a seasonal pattern? And is there a trend? So the seasonal pattern is there some kind of a pattern in the data which repeats on some predictable time frame. So for example, is there a difference between summer and winter? Is there a difference between weekdays and weekends? Is there a difference between the beginning of the month and the end of the month? Okay, so is there a regular pattern that we can see? And then the question about, is there a trend, which means, over time, is the data going up, or is it going down, or is it staying the same? Now, trend obviously can change. So you might have an upward trend for a bit, then it might stay the same, then it might go down, and then it might stay the same. So trend can be steady over a period of time, or it can be, or it can change quite regularly. I mean, that's one of the problems with the stock market, is that the trend is really unpredictable. It can go up for a period of time, it can go down for a period of time, it can go up then down and up and down, and you just never know when that pattern is going to repeat. So if we look at this data, we ask ourselves, is there a seasonal pattern? So if we look at that oval there, that blue oval, I've put a line around a year's data, so we can see that the first data point, which is data point 2, which is slightly outside of the oval there, sorry about that, is quite high, and then it goes down to the second point, point 3, and then down again to point 5, and then it pops up a bit. So it looks, like applications might be high at the beginning of the year and then go slowly down and then jump up at the end of the year. So if we look to the next year on, so points 6, 7, 8, 9, we can see that pattern repeats itself. So high at the beginning of the year, then going down and then up at the end. And then if we go to the next year, starting at data point 10, again it goes, that pattern seems to repeat. So it goes down for the first 3 and then it jumps up for the last one. So is there seasonality? It does look like there is seasonality, and it looks like the seasonality is that the highest applications are at the beginning of the year, and then it goes down, and then it comes up at the end. So maybe essentially people are applying around the end of the year and the beginning of the next year. So is there seasonality? Yes. Is there a trend? Well, now that's a little bit more difficult. If we look at data points 1 to 11, it looks like the data is fairly flat. So there's not an upward trend, there's not a downward trend, it's fairly horizontal. However, around data point 11, and I've drawn that vertical red line, it looks like something has happened. So all of a sudden, from data point 11 onwards, it looks like there is an upward trend. Okay, so data points 13, 14, 15, 16, 17, 18, 19, it looks like there is a positive upward trend from that point. So the question is, would we be confident to predict in the future? Well, I think if we were predicting into the future, then we would expect the seasonality to continue, but it's unclear what's happening with the trend. So it might be that trend continues for a bit, or it might level off, or it might come down. So in terms of confidence, I'd be confident that there is some kind of a seasonal trend, but I would not be confident that I would know where the trend is going. So seasonality, yes. Trend, no. Okay, so that would be my interpretation of that, and that would be my level of confidence regarding making forecasts for the future. Okay, so now one of the things that is used a lot is something called moving averages or smoothing. So what that means is, if we look at the actual data, which is the blue line, you can see that it goes up and down quite a lot. Okay, so when data goes up and down quite a lot, it can be difficult to see the underlying trend in the data. So what people do is they take a moving average, which is basically what they do is they take, for example, with an interval 2, they'll take two adjacent data points and take the average and plot that point. Okay, so they'll just go along 2 by 2 by 2, taking the average and then plotting the average value. And so if we see interval 2, that's the red line. Now you can increase the interval, so you could take an interval of 4, which means you take 4 data points, take the average, plot that point, then and you move on one, take the average of 4 and plot that point, move a 1, and basically the bigger your interval, the more the trend is smoothed out, so you can see the trend. So interval 2 and interval 4 and interval 6, they're all fairly similar, but you can see that the interval 6 one is pulled down a little bit too far, I would say. So it looks to me like interval 2 or interval 4 is doing a better job with this data, but it just lets you see the underlying trend in the data more clearly. So smoothing can be useful if your data is jumping around quite a lot. So here's another example of a time series. So let's have a go at that. So here what we have, well, let's just read the briefing. So as part of a review of past and future gas consumption, your analyst produces the plot below. It shows the most recent monthly data on consumption of gas in the UK, and data starts in May and ends in September. So there are nearly 3.5 years of figures. Okay, so if we look at that data now, gas consumption, the first thing you would probably think is seasonality. There must be some seasonality, and quite clearly there is clear seasonality there. So we can see that gas consumption is higher in the winter and lower in the summer, and that's because gas is used significantly to heat houses in the UK. So we would expect to see seasonality, and it's there. Okay, so I've put a blue circle around 1 year of data, which starts, so that's May, June, July, August, September. So it starts around September, and you can see that the gas consumption goes up, and then for the winter months, and then comes down for the summer months and goes up for the winter months. So is there seasonality? Yes, absolutely seasonality. Now, what about a trend? Well, that's a little bit unclear, I think. So I've put a line through the winter months which might suggest that there's an upward trend in the data. But that could be a bit misleading, couldn't it, I think? So actually, if you look at the figures for the first 3 winters, there does seem to be a bit of an upward trend. But if you actually look at the data for the last 3, it actually looks fairly flat. So it's not at all clear to me whether there is an upward trend in that data. And it could well be that obviously consumption is heavily influenced by weather and the temperatures of winter. So that those sorts of upward trajectories might just simply be because that winter in the middle was quite a cold winter and they used more gas in that winter. So I think it's uncertain, whether there is an upward trend in usage there. So I don't think we can say. If we look at the summer usage, that's at the bottom there doesn't seem to be any increase. All of the years that we can see there have figures around 3 million tonnes of gas, and it stays fairly consistent at about 3 million tonnes. So I don't think there's any evidence of upward trend in usage of gas in summer, but there might be some evidence of upward trend in winter, but it's not at all clear to me. So again, if we were making a forecast into the future, we would say, yes, we're very confident that there will be a trend in terms of, sorry, not a trend, there will be seasonality in the data, but we're not at all clear about whether there's a trend. It looks like the summer months will stay flat at about 3 million tonnes, and there might be an increase above 9 million tonnes going on in winter, but it's not at all clear. Okay, so it's really important with forecasting that we don't try and make a forecast possible when it's not possible. We should be really open and honest about that. Now, another approach to forecasting is to use regression. So we looked at regression in a previous session. So if you've got data like that, which is clearly going upwards over time, you could decide that you want to summarize that upward linear development using a regression model. So there we've got a model which is production equals 12 times time plus 21, so that's y equals mx plus c. And that has an r squared of 0.92, which is really strong. So that looks like a very successful piece of regression. But we need to be very, very careful, because if you remember when I spoke about regression, I said that normally in regression we are looking for a causal relationship between the dependent variable and the independent variable. So in this case, the dependent variable would be production and the independent variable would be time. But of course, there is no causal relationship there. Okay, so just because production has increased over the previous period doesn't mean it's caused to continue increasing forever. And of course, in reality, it won't keep increasing forever. So that's not a causal relationship. So we have to be very careful. So the future production could well level off, or it could even start coming down. In fact, you could argue that there's some evidence that it might be slowing down, although it's not clear. So regression is useful. It can be useful to put a regression line through data, but we have to be very careful, because this is not a causal relationship between production and time. Just because something increases doesn't mean that it has to increase forever. So another approach to regression analysis is more reliable, which is what's called causal analysis forecasting. So that's when we actually look for underlying factors which actually have a causal link with the data that we're interested in. And if there is, then this will be a more accurate way of predicting the variable. So, for example, a strong relationship between sales and advertising. So let's say, we advertise more and we get more sales. So we advertise more, we get more sales. And so over time, we might see a causal relationship between sales and advertising, which is what we would expect, wouldn't we? We would expect advertising to have a causal link to sales, because that's why we do it. We wouldn't spend money on advertising if there wasn't a causal link to sales, or at least some positive causal link to something that we thought was important. Now, causal analysis requires more data, and we may need to study multiple variables to get some kind of reliable model there. But if we can build a regression model which actually has causal links, then it's going to be a more reliable model. Now, it's popular, especially in sales and marketing, and there are many factors which can drive sales. So, for example, market conditions, so political, personal income, economic growth, those sorts of things will affect sales. Competitors' behavior can affect sales. So, if a competitor reduces their prices, then we could see that impacting on our own sales. New products or services, obviously if we launch new products or services, or if our competitors launch new products or services, then that will affect sales. Brand factors, so if our brand becomes more effective, awareness or perceptions of our brand increase or improve, that will affect sales. Pricing factors, so if we reduce our pricing, that would affect sales. Distribution factors, so new channels or new locations of stores or some improvement to the way that we distribute our product, that could affect our sales. Promotions, so if we decide to do 2-for-1 sales, or we provide some other form of attraction to our product, maybe we increase quality or we do social media activities, then that's going to affect our sales. So sales experience, so the number of sales staff, the skill of the sales staff, the training of the sales staff, that might affect our sales. Customer experience, so if our customer experience is improved for whatever reason, that will affect sales. So these sorts of causal analysis models are fantastic if you can do them, but because so many variables affect sales, sometimes it can be quite difficult to build these models, and we need to be a little bit careful. We might be able to generate useful models by focusing on certain variables, but we need to remember that we're going to be ignoring other variables, so we need to be careful that we don't get too confident in these sorts of models. So that's just giving you a quick introduction to forecasting. Like I said, the golden rule of forecasting is get a time series graph up and have a look at it. That's going to tell you, that's going to give you a very good idea about seasonality and trend, which are the key things that we're looking at. There are other tools like moving averages which can help you see trend more clearly, and we can use regression to do forecasting, but we need to be very careful. If we're just looking at a variable against time, that's not a causal relationship, so we need to be careful. If we do build causal relation models, we need to be careful because there's so many different variables that can affect things like sales. Our models might be too simplistic to be reliable, and if we have seasonality and trend happening, then it's very difficult to model that. It's quite an advanced form of modeling. So my advice to clients is, always look at a time series graph. They are fantastic things. They are very reliable, and you can see very clearly whether forecasting is going to be straightforward or really difficult.